In this video, we're going to see what is structural equation modeling, what's the theory behind structural equation modeling. We'll also take an example to understand how to use structural equation modeling. We'll start with the basic introduction. We'll then see what is path analysis, and then we will see what is factor analysis, which is part of structural equation modeling. Then we will see the different construction of structural equation modeling, which is to say hypothesis testing, specification, identification, estimation, and then we will take an example to understand how to use these constructs, and then we will conclude. Okay, so here is the content. Okay, we'll start with the introduction. What is structural equation is all about. So it's basically a concept that uses the combination of statistical techniques such as exploratory factor analysis and multiple regression. Okay, if you are familiar with exploratory factor analysis and multiple regression, you must be knowing that both are used for different reasons, right? Exploratory factor analysis is something used to explore your data, to see whether your data has groupings, to see whether factors in your data can be combined together to form some factors. On the other hand, multiple regression analysis is used to sort of find the impact of change in one set of variables on another variable, which is known as the dependent variable or the response variable. Now, structural equation modeling combine both. So you don't need to do exploratory factor analysis separately and do the multiple regression to confirm your exploratory factor analysis results. You in fact can combine both and do it in one go, and that's what is the motivation behind structural equation modeling. Okay, or in short known as SEM. Alright, so in such cases, your independent and dependent variable can be both continuous and discrete, right? Unlike in multiple regression analysis, where the condition here is that you have to have your dependent variable as continuous as opposed to discrete values. Okay, so for discrete values, you go in for more discrete regression analysis such as logistic or a probit regression modeling. And independent variables can be any predictors or any causal variables. Okay, it could again be continuous or discrete. Structural equation modeling is also known as causal modeling or analysis of covariance, and we will see why it is called causal modeling, because the reason why structural equation modeling is very popular is because it's used to find out the different causes of an event or a response. Okay, and it is studied at a very detailed level. Okay, and that's where path analysis and confirmatory factor analysis are of use, and these are basically the two aspects of structural equation modeling. The two components of SEM are basically the confirmatory factor analysis known as CFA and the path analysis. We can study them separately. We will see how they're slightly different and the motivation behind each one of them. We'll start with path analysis. Now this is some sort of regression analysis, but we will break the regression into few segments or few different forms and then combine later on. Okay, so basically path analysis, as the name suggests, it is to study the causal behavior between variables through different paths. Okay, through different paths. We will see a diagram in the next slide to understand how we can have a path that will give us a better insight about the relationship between variables. So the steps followed in path analysis is very simple and straightforward. You draw a path diagram according to the theory, and then you construct one or more regression analysis, and then you compare the regression estimates to the theoretical assumptions based on how you have drawn the path, and then if needed you just modify the model by removing or adding connected paths, and then finally you can present your output to the audience, and you can write about it based on what the findings are. So here is an example. Okay, so dependent variable in this case is task. We want to know performance in a given task is related to age of the person who is performing the task, the education of the person, and the willpower. Okay, so these are the three independent variables or covariates that affect, or we think would do affect somebody's performance in performing a task. Now we also could see that you know willpower will not just be affecting tasks, it will also get affected by somebody's education, or probably it's also uh, could be affected. I mean, age and the education could be affected. I mean, they could be interlinked. Okay, and education could be affecting um, willpower, and age also could be affecting education. Okay, so all that possibilities of relationship can be there, and we can surely see whether that's true or not. So we'll take just one relationship, extra relationship, apart from the normal thing that we are seeing here, which is to say whether the task is getting affected with somebody's age, education, or will. Now we see here that education might also be affecting will. So thereby education having a direct impact on task performance directly, and there is also an indirect impact through willpower. Okay, so we have drawn here a path. So this is how the path looks like. Okay, so as I've already said, there is a direct path, there is indirect path. The direct path, of course, is the colored in pink, um, and the indirect path is colored in dark yellow. And you can see education is having a direct impact on task, and also has an indirect impact on task through willpower. All right, so this is basically is a very simple form of path analysis, where before even you starting out with your regression analysis, you just draw these diagrams on pen and paper just to understand. Okay, what you might wonder, why do we do that? Because anyway we can just go and directly perform a regression analysis. What's the purpose of drawing these diagrams? Well, the main motivation here is that your knowledge about this given problem, so we are basically including the prior knowledge about this given problem into the regression analysis. Now if you do not include your prior knowledge, regression analysis will simply find out the correlations between the set of the independent variables and the dependent variable. The causal behavior, of course, can be explained, but it can be explained in a much better way if you include your domain knowledge, rather your prior knowledge about the given problems. Now if you know for sure that education has some indirect impact, you better consider that beforehand, before even going ahead with the modeling. And that's where path analysis is different from the regular regression analysis that we do, wherein we do not quite provide the knowledge, prior knowledge explicitly. Of course we do sometimes, but you can do that without even giving. But here there's an explicit emphasis on that. You provide all that before even you start out with the regression analysis. And here is what we have seen, that education impacting task indirectly is something that isn't going to be captured directly in the model unless you explicitly provide that information. Alright, so here we have two equations. First one is age, education, willpower. They will affect task, somebody's performance in performing task will get affected by his age, education, and willpower. And then education will affect willpower. Okay, so there will be two regression equations. And once we have this regression equation, we will find out the beta parameters. Okay, and the beta parameters will talk about, or rather will give us an indication that how is the strength of the relationship. Okay, so that's one reason why sometimes we better standardize these variables so as to see the strength of relationship and compare the strengths. Okay, so we can take other examples also. Okay, so here is another examples where education and salary and is impacting the performance of some task. Okay, this is called decaf coffee. So it's like, you know, you're sort of performing some task, and how is getting affected, how is it related to education and salary. Of course, education salary can directly impact somebody's performance, but education also impacts, it has a direct relationship with salary as well, where salary can be modeled as a function of education. So that has to be brought into the linear regression equation. When we took the data and then we did the analysis, you will see there are two equations now. First, this dependent variable is now taking independent variable as education and salary, and the other dependent variable is salary itself, which is an independent variable in the first equation, and the independent variable in this case is education. Okay, so here is what the data set looks like. You have education, you have salary, you have decaf coffee, and then you did the regression. So what we did is that we first regressed salary and education with a decaf coffee, which is the dependent variable, and then we regressed salary with education, and we found out the beta parameters, and we saw whether the beta parameters are significant or not. Okay, so just look at the beta parameters. Here we have 447, sorry, this constant. Education parameter is 33.224 and salary is 0.108, and both are significant. As you can see, the p values both are significant. Similarly, when we regressed salary with education, we found out the parameters to be the beta parameters to be 212.581, and it's also a significant variable. Once we have that, we can put that in the path analysis figure, and we can compare the strength of relationship, and that's a better way of understanding, you know, the relationship between a set of variables than simply, you know, making a straightforward multiple linear regression. So this is how it looks finally. Okay, once we have the beta parameters, we can simply put that on the diagram to